Hello, this afternoon in Chicago, we are here with Menno Ellis, the Executive Vice President of Healthcare Solutions for 3D Systems. Menno, thanks for coming.
Thank you, Peter. Glad to be here.
Excited to chat a bit about the future of 3D printing. And we spoke a bit earlier with Ben Johnson and Gautam Gupta around what's happening now. I'd love to hear a little bit further out where you guys are going, what you're looking for, what kind of technology you've developed. It's exciting stuff.
No, thank you. I'd love to share some ideas with you on that one. First of all, from our side, very excited about the partnership between our groups. We really do believe very firmly that the future of medicine is around personalization, and the combination of our respective companies really enable us to make some pretty significant strides in terms of the type of services that we can provide both to the physicians as well as to the patients, improve the overall patient experience, and allow us to scale this business that, as 3D Systems, we started about 10 years ago, and really can kind of make the next significant leap forward together with this. So that's one area where we're very excited about doing. As we think about that, we have had a traditional set of offerings and materials specifically that we have brought to bear on this, right? There's a number of different materials that the medical industry is quite familiar with already. If you think about titanium, cobalt, chrome, and nylon, that have established a pretty good place in the marketplace in terms of where and how people use them. And most recently, within the last handful of weeks, we actually announced another new expansion for our company, and that's in the world of PEEK. And PEEK is a material that's been known to the medical industry for a number of years already, for both for instrumentation as well as implantology. And then traditionally where people have used this is by milling PEEK, machining PEEK. It's done well. It gives a number of benefits that physicians like to see. But the challenge is so far, nobody has been able to 3D print PEEK. And so that causes a couple of limitations. Number one, from a cost and efficiency standpoint, whenever you machine something, you end up with a lot of waste. It can also be somewhat time consuming. And you're also somewhat limited in terms of some of the architecture and some of the designs that you can accomplish with it. And by having the ability to 3D print now, we overcome those. And so we have been looking both internally and externally for quite a while to see how we kind of break that technical challenge and being able to print it. And we found a company that we evaluated for a while in Germany called Kumovis. They have that capabilities. They have a real product that's out there in market. And so we said, this is it. This is the marriage that we need to make happen. So that's an acquisition that we made. And so we can now take that PEEK offering into the marketplace, expanding what we're currently doing with the traditional metals and plastics already. So it's very, very, very exciting stuff. And so it fits very well also with what you and I are partnering on, is because it's a very, very effective material to look at different types of implants that can be personalized. And again, because we're 3D printing them, we can personalize on a very cost-effective basis.
Yeah, it really opens up some doors. You know, not everyone that's going to be listening to this is going to know PEEK and what it does. A lot of engineers do, because we've run into it for a while.
Yeah.
What are the current applications for PEEK in the market today?
Yeah. So what you see quite a bit already is in cranial implants and some of the restorations in that part of the body. You see a little bit of it also within the spinal space. And one of the big benefits of PEEK is the radiotranslucency. And so once you've implanted into a patient where a metal device could basically obstruct the view of the radiologist, you get past this, right? And then in certain circumstances beyond that, also from a patient standpoint, people prefer to not have a big piece of metal in their body when not necessary. So that's quite exciting, and so that's why people really are very bullish on being able to do things like that.
No, I agree. I think the potential in cranial maxillofacial, you guys are already doing a ton of work there. Now applying a patient-specific version of that very cost-effectively and time efficiently. It's quite interesting.
Yeah, very excited about that.
I believe last year you acquired another company that was maybe a bit earlier stage,
Yep.
and that company was called Alevi.
Alevi, indeed, yeah, good
Great.
memory. So Alevi is a bioprinting company, and so we have, as a company, we've kind of started making some more public moves around what our ambitions are within the bioprinting space. We started this a number of years ago through a partnership with a group called United Therapeutics that we initially engaged with to be able to print human organs, and specifically lungs was kind of the big challenge in saying, how can we take the knowledge that we have with 3D printing combined with their biological expertise and say, can we do this, right? I mean, the human story is quite obvious, right? People are looking for implants, there's not enough organs available through the organ donor banks. Can we create these things? So we've been working with those folks for a while, made some nice progress to the point now where we are comfortable talking a little more publicly about the things that we're doing. And then with that, we said, okay, that's kind of the tip of the spear, right? And say, those are things that go directly into the human body. But there are very other exciting things that you can do on the bioprinting side that don't go directly into the human body. And that's where Alevi comes in. So Alevi is started off as a university spin-off about 5-6 years ago, and they basically created accessible and pretty easy to use desktop printers that could handle biological materials. And if you think about so much of the medical advances need to go through a fairly significant exercise and time of research and testing. And so traditionally what has been done is, you take your biological material, put it in a well, test it and so on, pipetting, things like that. You can go a long ways there, and you can test healthy tissues, you can test diseased tissues, there's a number of things you can do. The limitation that you have there is you're basically operating in a two-dimensional environment, because what you pipette in and out is however the material decides to settle in that well. And so that's where 3D printing now gives you an opportunity to mimic the human body and the cells in the human body more accurately by recreating the three-dimensional structures the way that those materials occur in the human body. So it's a much more realistic testing device, and because you can 3D print it, you can replicate that same cell structure, let's say, time after time after time, and thereby giving these research organizations the opportunity to now start doing tests in a larger scale in a more reliable fashion. A lot of that started initially with universities, right? They're kind of on the cutting edge and like to experiment different research methodologies. And then sooner or later, the pharmaceutical companies have kind of started picking up on that too and said, okay, this is really a nice way for us to accelerate what we're doing. And if you think about a typical pharmaceutical development timeline, 10 years is not out of bounds. Right? And so if you say, you know what, by giving people access to these repeatable, predictable research tools, we can really take a lot of that timeline and shorten it, which, I mean, you can't even imagine what that's worth in terms of lives saved, dollars earned, things of that nature. So that's kind of where Alevi comes in. Now, what really gets interesting there is if you now say, okay, now let's take the combination of these two different vectors that we're pursuing, and what can we do there? And if you think about today, when we talked about the implants, right? We talk about PEEK, we talk about different metals, things that are well accepted by the human body and they work well. But at the end of the day, you're still inserting a non-cellular piece into the body. And so the next step that we're now working towards is say, can we take our biological expertise, the printing expertise, and start combining these and now start thinking about either implants of different kinds that can be biological matter, or perhaps fillers or additives or things like that that you would add to those metal implants.
To make them more bioactive.
You got it, right? And quicker to be accepted and absorbed by the human body, right? So improving the chance of success of those implants that you make, and shortening the recovery time on those things.
That's incredible to think about. If we think where the industry started in cementless hips 20 plus years ago, 30 years ago, it's been a while. We would spray some hydroxyapatite onto a stem and hope it stuck. We've advanced the technologies with 3D printing to allow for incredible pore structures that, as an engineer, I dreamed of. I actually remember one time I picked up snow, and I studied snow and how could we make this? But you could 3D print that level of detail now, which was never even fathomable 15 years ago. But now the next level would be to engage even more bio-responsive material inside of that for faster healing, better absorption of the material, and longer implant or potential for longer implant success.
Right. Yeah. And so for us, I mean, we're very excited in the sense that we kind of have quite a bit of involvement in each of those vectors, right? So the first one, talking about organ manufacturing, which in a lot of ways is the holy grail. Supporting the research efforts and shortening medicine, pharmaceutical development life cycles or timing. And then the third one, applying that knowledge to medical devices that would be implanted into the human body in some form. So they're the kind of things that are going to make an enormous difference in the way that medicine is practiced and the way particularly restorations and implant type surgeries are being practiced. But ultimately, again, you're looking at something that is going to make the lives of the patients better, more comfortable for the long term. And ultimately, that's going to benefit every single one of us.
It really will. And I think as we started, when we first met over a year ago and started talking about things we could do, it went right back to this point in time where I thought about some of the reasons why Enhatch had this kind of virtual, not virtual, but like a rebirth halfway through. Where we were always servicing the medical device industry, and then I had a series of family challenges in health from my mother and father, and I felt that. We had a close member of the family pass after knee surgery, and it kind of made me change and rethink. So before we've even ever met, I wrote this idea of the future, and you guys are investing in it and building in it, and it's something we want to be a part of in supporting 3D systems. So we're really excited about the potential.
Yeah, no, you hit it on the head, right? I mean, everybody has a personal story like that sooner or later, right? Some of it closer than others, but it's it's incredibly exciting and also very rewarding to be able to participate in things like that.
It is.
Yeah, excellent.
Well, thank you so much for coming and chatting with us.
Yeah, thank you so much, Peter. Appreciate it. Thank you.